This is the Mathematics Education Podcast from mathedpodcast.com. Welcome to the Math Ed Podcast. My name is Sam Otten from the University of Missouri, and with me is Mimi Engel, an assistant professor of public policy and education in the Department of Leadership, Policy, and Organizations at Vanderbilt University. Mimi, thanks so much for being here.
My pleasure.
We're going to be talking about a recent study that Mimi published with her co-authors in the journal Educational Researcher, and that study was entitled Mathematics Content Coverage and Student Learning in Kindergarten. So we're going to be really talking a lot about kindergarten and digging into the mathematics that's going on in kindergarten in a second. But Mimi, I actually want to back up first and just ask you a little bit about your background. So where did you do your graduate studies, and then what was the focus of your dissertation study?
I did my PhD at Northwestern University in the School of Education in a program called Human Development and Social Policy. So my orientation has always been around those two things, thinking about how children develop and how that intersects with public policy. And my dissertation work was actually on teacher labor markets. In particular, it was on the demand for teachers, how districts and schools make decisions about which teachers to hire for vacancies.
Oh, wow. So it's interesting to have you studying public policy issues, but you also have been entering into our field, and why we have you on the Math Ed podcast here is because you have been studying things related to mathematics, and specifically what I would call mathematics curriculum, or what it is that happens in kindergarten classrooms. And I, for one, really am excited to have you as a guest here because my two sons are preschoolers at this point, but my eldest is going to be headed to kindergarten next year. And my wife and my mother are both elementary school teachers, so I just find myself thinking a lot more about elementary curricula and especially kindergarten. So what was it that led you now to a study of mathematics in the kindergarten level?
I'll backtrack for 1 second and just note that I worked on this line of research while each of my children went through kindergarten, and it was very interesting to be doing this work and having kids who were kindergartners. So I too have taken that perspective and I enjoy talking about this work with parents of kindergartners. This work actually evolved from a strand of research that I started in graduate school with my advisor at the time, who's Professor Greg Duncan. He's now at UC Irvine. The work that we were doing was focused on early skill formation and specifically what early skills are most predictive of later school-related outcomes. Mm-hmm. We were looking at, early math, early reading, and then early socio-emotional and behavioral skills, and seeing, well, which of these at kindergarten entry and changes on these in kindergarten predict later outcomes. And something we found that we didn't quite expect was that math was highly predictive, not just of your later math learning, which might be intuitive, but of your reading outcomes and of other important school-related outcomes through 8th grade and beyond. And so as a policy person and as a human development person, I and my closest collaborator on this, who's Amy Cleasons at the University of Chicago, became very interested in digging in deeper and learning more about math and thinking more about early mathematics teaching and learning and focusing on kindergarten. So that's what got us to thinking about kindergarten mathematics curricula.
Even though I don't do work directly in this area, I've definitely noticed a lot of conversation about kindergarten curricula and how there's kind of been an increase in the academic rigor expected of kindergarten. So comparing it back to when I was going to kindergarten, where it was mostly like learning school and learning social skills, and then the academics kind of pick up in first grade and on from there. And nowadays, it's really kindergarten already is an academic grade level, and they have, fairly rigorous standards that they need to meet. Is that a fair characterization of kind of where kindergarten has been moving in the last 10 or 20 years?
I think it is a fair characterization from my read of the literature. There's a great piece by Jennifer Russell from 2011, published in AERJ. She does a kind of a historical analysis of kindergarten, and what she shows is that kindergarten started to become more academic quite a bit farther back than what we think. And when it started to become more academic was when it shifted to being housed in what we now think of as K-12 school buildings. But at the time, were not that. Kindergartens functioned more like a typical preschool and were often not housed with elementary schools. So as kindergartens moved into elementary school buildings, they saw an increase in the how kindergarten was talked about in terms of academics. Then we've seen a tremendous upswing, and this is, in my opinion, best documented by Daphne Basak, who's at the University of Virginia, and some co-authors of hers, really carefully documenting and showing, with the same data sets that I use, that in a relatively short amount of time, we're talking 1998-99 being the base year, and then 2010-2011, the next year, kindergarten teachers report kindergarten having become much more academic in nature.
Okay. So what were the questions now in this particular study in Educational Researcher? What were the questions that you wanted to try to answer within this, context of kindergarten and the mathematics content that's happening in kindergarten?
Yes. So as my collaborator, Amy Cleasons, and I, and we have other co-authors on this work, Tyler Watts and George Farkas, who are both at the University of California, Irvine. And we wrote a paper that appeared in Educational Evaluation and Policy Analysis. It was published in, I believe, 2014. And what we started to see, what motivated that paper, is we had been expanding that work on, how does what you learn in kindergarten predict your later outcomes? And we had access to teacher survey items where teachers were reporting what content they taught in kindergarten. We also had access to diagnostic testing that was included in the same data set, assessing what mathematics kids knew. And what we started to see working with the data is there seemed to be a mismatch. And what I mean by a mismatch is it seemed like kids were starting kindergarten, the vast majority of kids, with mastery of certain mathematics concepts. And the concepts I'm talking about are basic ideas of numbers 1 through 10 and knowledge of basic shapes, circle, triangle, rectangle. And
kind
as
of
a
naming
parent
the shapes almost.
Yeah, as a parent of preschoolers, you're probably tuned in, and a math ed person, you've probably tuned into what many kids know and what many kids are capable of doing at those ages. What we were seeing was that the tests revealed what earlier research had shown with smaller data sets, which is that kids enter kindergarten, the vast majority of kids, with certain mathematics skills already in place. And what we thought we were seeing was that teachers were spending a lot of time on the content that kids already knew, that basic number and basic shapes. Mm-hmm. And that led us to publish our first paper where we show this to be the case. And then a new data set was released that allowed us to replicate or partially replicate our analyses. And what we wanted to see was what kind of mathematics content are teachers reporting covering in this newer data, which was from for kids who were in kindergarten in 2010, 2011. Do we see the same associations in terms of student learning that we saw in our original analyses?
Mm-hmm. Yeah, I'm thinking back to what you said about the situation with reteaching what they already know. I can definitely see it where a student learns to count to 10 or learns to count to 20, and there's sort of just this fun that the adults have and the child has to just keep reciting that. Like, wow, yep. I know how to count to 10. Let me do it again. And next week I'm going to do it again. And I'm going to do it again. Or count to 20. And then everybody wants to hear you count to 20. And it's like a great performance piece, but it's not really pushing their mathematical learning to any further steps or any further depth. And it could be the same with shapes, like, oh, I know square, I know rectangle, I know triangle and circle. And then let me just keep showing you and asking you about those exact same shapes every time for like month after month. So it's kind of fun because the student is having success in those recitations, but in terms of pushing their mathematics forward, it's kind of just stagnating, right? So even though you feel good about it and it's kind of impressive to see the student or the child do that stuff, it's not really pushing them forward.
Yeah, what we document, and keep in mind this is not an experiment, right? We're using, this is secondary data analysis, so I would describe these as carefully adjusted correlations. So we're trying to isolate the relationship between this content and what students learn. But what we show consistently in both data sets is that the time teachers spend on that basic content that kids in 1998 had already learned when they started school has a negative effect on student learning in math across the kindergarten year. Kids learn less. Conversely, when teachers report spending time on more advanced concepts such as basic single-digit addition or subtraction, we show positive effects on learning, or we show growth in mathematics learning for kindergartners.
Mm-hmm. Yeah, so that is, to me, the compelling idea from this study. And so I'm speaking with Mimi Engel from Vanderbilt University about her study, Mathematics Content Coverage and Student Learning in Kindergarten. And so you had the two data sets that you are correlational, but you really took a careful look at them and drawing some very careful conclusions from them. You've been talking about the basic mathematics content and the advanced mathematics content. And if I understand it all correctly, the basic content is basically defined as content that the majority of students enter kindergarten with already. Is that right?
Yes. This is a great place to spend a minute because this is an important point for folks to understand about the study, and it's something that we were pushed in really positive ways in the peer review process working on these articles. It's interesting to be a policy and human development person and be reviewed by people who are really deeply immersed in math curriculum. So there are many different ways that one can think about what would be basic or what would be advanced content. And you can think about it in terms of kind of the depth with which certain content is taught, right?
Yeah.
That's a different angle, and unfortunately one that we can't tackle with the data that are available to us. What we're able to do in 1998, luckily for us, the National Center for Education Statistics, which fielded both of these awesome studies and makes these data sets available for researchers, created mathematics proficiency levels or mastery levels for each sample child in the data set. So we were able to tell whether a child was proficient in different areas. And the areas for kindergarten were basic counting and shapes, patterns and measurement, place value and currency, and addition and subtraction. And what we see is that kindergartners almost across the board are proficient in basic counting and shapes, and the majority of them are proficient in patterns and measurement as defined by these tests. But they have not yet mastered at kindergarten entry, for the most part, simple addition and subtraction, or notions of place value and currency.
Okay. So a very kind of functional definition because of the data that you're working with to be able to draw meaningful conclusions, where somebody from mathematics education theoretically might want to define them differently that wouldn't have made sense for the data that you were analyzing.
Absolutely. There are always trade-offs in working with different kinds of data. So this study has actually motivated us to go into the field, and we're in a large urban district doing observations of kindergarten classrooms. So we're going to dig in deeper to figure out what this content looks like at a more granular scale, the depth with which it's taught and the pedagogy that teachers use, but that was not something we could do justice to with the data we had available.
So first of all, looking across from 1999 and then to 2011, what were the differences or what were the similarities that you saw for the content that was covered?
So the take home here is that teachers continued to spend as much or more time on the basic content that they reported covering in 1998. So teachers did not cut back on the days per month they reported teaching things like basic counting and shapes or patterns and measurement. Interestingly, we saw teacher reports of time on more advanced content increase between those two time points. I think teachers went from reporting about 8 days per month on more advanced content in 1998-99 to closer to 10 days per month on more advanced content in 2010, 2011. So that is one difference that we saw, or both a similarity and a difference. Time on basic content didn't shift. Time on advanced increased a little bit. But there's an important second lesson here that I'd like to mention as well. One of the important findings, most important findings for me in this study, and this is, as a social scientist who's deeply interested in the notion of replication, right? Can you find something in one data set, or one researcher finds something in one data set? Does another researcher find it in the same data set? Or do I, the same researcher, find that same thing in a different data set, right? Is this a pattern?
Yeah.
And what we found is that the pattern of what kids learned from, which content kids learned from, and which content seemed to actually kind of dampen kids' learning or result in less steep learning trajectories for children, that pattern held really, really cleanly across the two data sets. So time spent on basic content has a negative association with student learning across kindergarten. Time spent on more advanced content has a positive association, and that was true in 1998 and again true in 2010.
Mm-hmm. When you say the negative relationship, is that kind of, is there actually a regression of learning, or is it just that it kind of dampens, like you said, or stops the learning from progressing as positively? Or is it actually that the basic content is somehow counterproductive? I guess my question would be, is it non-productive, or is it actually counterproductive to spend so much time on the basic mathematics content?
Yes, it's a good question. I mean, my inclination here, and I want to replicate this, again, using data that I've collected myself in the field. So what we see is that it dampens learning. Students learn less in math when you spend more time on basic counting and shapes. And what I imagine is that, if you think about teaching, and many of us teach, it's not as if you would start, I can't fathom starting teaching kindergarten and not talking about and teaching a little bit of basic counting and shapes.
Right. Mm-hmm.
But the thing that, right, that seems nuts. The thing that I'm hung up on, and what I think might be going on after spending some time in kindergarten classrooms, is what you alluded to in a really nicely stated way earlier on, which is just that there's this positive reinforcement happening where kids know it, it makes teachers feel good, it makes kids feel good. Not everyone who goes into teaching kindergarten has dreams of teaching mathematics. So I think there's this feedback loop that happens that keeps kids and teachers spending a lot of time on basic concepts in math that are already known. The negative coefficients for me are not a good thing. We show that this is negatively associated with student learning. It doesn't mean that they know less than when they started. It means they're learning less than they could be.
Mm-hmm. So, I think an obvious question then is going right along those lines of kind of taking your findings and putting them into a real context, or thinking about them through the lens of a teacher who might have kindergarten classrooms. What do you see as the implications for practice that come from this study?
Yeah. What we're thinking about, and part of what we're doing in the field, doing observations of kindergarten. In our original study on this, we had several hypotheses about why this might be occurring. One is that it's driven by curriculum. Another is that teachers aren't comfortable moving outside of the most basic mathematics content, and that's in particular some kindergarten teachers. Another is the positive feedback loop that you mentioned, right? That it feels good to share answers that you know, and it's knowing young children, having that opportunity to raise your hand and know something feels good, and taking more risks and trying to figure something out sometimes can be less comfortable for all of us. What I'm interested in exploring is whether, and this is I think a project that we'll be working on for a while, but I'm interested in exploring whether shifts to curricula that direct teachers to spend more time on these more advanced topics and less time on the more basic topics might in fact have positive effects for the vast majority of kids. So in some ways that's tricky because we're talking about, curricula exist in their current form. So we'd be talking about tweaking what's going on in a classroom. But the reason it intrigues me is that my gut, and from having read various pieces about mathematics instruction and thinking about mathematics knowledge for teaching, work by people like Heather Hill and others, right? It seems pretty hard in some ways to help teachers shift kind of their pedagogical knowledge of mathematics, to change kind of how they teach. That I think this is maybe going to get some pushback from listeners, and I'm interested in engaging that. But I've read several studies recently that have made me think, wow, it's hard to change mathematical knowledge for teaching, kind of when you're thinking about pedagogy and when you're thinking about kind of teachers' conceptual understanding and ability to move that forward. I'm wondering if, in a sense, lower-hanging fruit, and that's probably a way policy folks talk more than curriculum folks, but something that we could go after that could have positive effects for kids is changing the amount of time that's spent on content so that it's better aligned with what they need. And I think that we already see this in reading instruction in kindergarten. I think reading instruction in kindergarten appears to be pretty individualized. And I say that both as a parent who observed her kids be taught in kindergarten and as someone who's looked at the data in the same data set for reading.
Yeah, I mean, I agree when you mentioned the 3 speculative explanations for this phenomena. It does seem to me, too, that the curriculum is the one that we could probably, with a doable amount of effort and in a reasonable time frame, try to make some changes on the kindergarten mathematics curriculum. Because I agree that the teacher knowledge is, that's a big challenge to take on as a field, and people are taking that on, but if the curriculum one is more modifiable, then that seems to make sense. And the feedback loop and how people feel about sort of sharing what they know and doing that one's kind of unchangeable, I would say. That's just something about human nature that we enjoy, kind of performing something that we've figured out. So that one's sort of unchangeable. Teacher knowledge is very hard to change and would have to be a very systematic, large-scale effort. The curriculum is maybe one where it's doable. You could find schools or you could find, districts where they might be willing to try to modify that mathematics curriculum for kindergarten, or you might be able to find textbook publishers that are open to, changing the amount of time that they put into those basic concepts.
Yeah, that's exactly where we're thinking there's the most potential to make headway, and thinking about it from a cost perspective, it's potentially less costly since it seems doable.
I'm speaking with Mimi Engel about mathematics content in kindergarten, and Mimi, I have one more question that I want to ask you that's not related to kindergarten, unless maybe it is, but I'm curious, if you weren't an educational researcher, what could you see yourself doing instead? And I'm hoping that you're not going to say a kindergarten teacher. Want to find something a little bit more creative than that if you have it.
Something that I am so grateful for is that there are people in the world who are suited to teach kindergarten, because I am not one of them. Kindergarten teacher is not on the list, though, like I said, I am so grateful for those folks. I actually think that the part that is, it wouldn't be a radical leap in a sense, because I think I'm a natural researcher, but I think what I'd probably be doing is discovering or cataloging plants. I love plants and gardening, and I think it would have been a slightly lonelier life than being an educational researcher, but I think I could have really, really geeked out and enjoyed doing work as a botanist.
Oh, wow. So I imagine you do have like a home garden or something like that, and do you do more flower or do you have vegetable stuff, or is it just a mix?
We do. I'd say we're more heavily fruits and vegetables, but we enjoy doing flowers too. And it's just, I've done it forever. I'm from Chicago, and I container gardened in apartments in Chicago, from when I was 24 on. I was like the weird person who had tons of tomatoes on her balcony in Chicago. So I've always done it and love to do both. And right now we have a volunteer pumpkin plant in our backyard that's taken over most of the yard and is producing these giant pumpkins that must have been from one of our jack-o'-lanterns from last year, but it's been interesting to watch it take over.
Oh, wow. And that can be a fall activity with the kids, too. It's always fun.
Absolutely. Yeah, we plan to have our neighbors come over and choose their pumpkins.
Well, very great. Well, Mimi, thanks so much for taking the time out to speak with us about your work.
My pleasure.